Okay, in this video, we're going to go over something called functions. And this is going to be just an introduction. We're going to cover these topics. We're going to cover some definitions, domain and range, and then what is function notation. And then we're going to try a simple problem, okay? So let's get started. I think the best way to introduce functions is to show you this equation here. Y is equal to mx plus b. And you all probably recognize that as just a linear equation called the slope-intercept form, right? And we know how this works. The slope-intercept form, and actually let's do this. Rather than just call it y is equal to mx plus b, let's just put some numbers in here. So, all right, so let's just say y is equal to 2x plus 1, right? We know that the b is where the y-intercept is. We know that the m is the slope, right? If we just did a quick sketch over here, we would know that the intercept again is right there. That's my b. We'll call that 1. The slope is up 2 over 1. And then here would be my linear equation. Okay? Now functions are really just the same thing as the slope-intercept form with just a couple of notation changes. Okay, now let me tell you what that means. Basically what we do for function notation is that we replace the y with what's called f of x. All right, so I'm just going to rewrite it as this. Okay, so the y is replaced by what we call f of x, and it's written this way. Okay, and this is how you say it in English, f of x. So in other words, the function of x. Now why do we do that? Well, basically what you're doing here, let me just finish one more thing. We can basically then end up saying that f of x is really just the same thing as y. Okay, so always keep that in mind. It's just replacing one for the other. Again, let's ask why we're doing that. What we're saying is that we have some kind of an x, right? Something along the x-axis that we're going to put into this equation. All right? So the x is the domain. These are where all the possible x values come from. Possible x values. Now, when we normally do problems, all the numbers in the real number system are possible x values, right? So let's say something like this. If I were to put in, this is like 1, 2, all right, let's put in 1. Let's say my x is 1. So what I'll do up here in function notation, I would go up and say, if my x is 1, what will my function be? Wherever I see x, I'm going to put in 1. And then I'll just go ahead and work it out. 2 times 1 is 2, plus 1 gives me 3. Notice that that's also my y, right? So 1, 1, 2, 3. And there you have it. So you would say f of 1 after it goes through this equation, or this function, is going to be equal to my y. F of 1, 2 times 1 plus 1 equals y. Then you solve. Y is equal to 3. So f of 1, my x value, produces my y value, which is 3. The y value is called the range. And that would be all y values created from the function. Okay? So it's just a different way of talking about things. The x values are also known as inputs. My y values are also known as outputs. Think of it like this. I have an x. I'm going to put it in some kind of an equation, or also called a function, and it's going to produce some kind of a y. So think of it as like an input-output kind of machine. You take an x, you put it in this little machine, and out pops the result, which is the y. And you produce always some kind of a coordinate. Okay? Now, let's actually try some simple problems, if that makes some sense. It might be helpful to do something like that. So let's try this. Let's say I have my domain, okay, and my domain is going to be a smaller domain this time. So instead of all real numbers, I'm going to say my domain, and I usually put it in some kind of a brace, is 0, 1, and 2. Okay? And the function is going to be f of x is equal to x squared minus 1. Find the range. How would I do that? Well, basically what I'm saying is I want you to replace all the x's with 0, 1, and 2 and do them one at a time, put them through here, and then find all the possible y values. So this is what I would do. I would say f, number 1, f of, let's take a number out of the domain. These are my x's, so x of 0. Wherever I see x, I'm going to put in 0. So x of 0 squared minus 1, because that's my function. And then I'm going to solve this. That'll be 0 minus 1, negative 1. So my range is now so far negative 1, and my ordered pair would be 0, negative 1. 0x produces a negative 1y. Let's do it for the second number in my domain. I would say it's f of 1. It's going to be replaced, remember where I see x, replace it with 1. 1 squared minus 1. Solve this, you get 1 minus 1. Get 0, my ordered pair is 1, 0, because if x is 1, my y is going to be 0. So now my second number in my range is 0. Let's do the third one. We'll say f of, let's try another number out of my domain, my last one, so f of 2. Replace it. Wherever I see my x, this is my function, wherever I see x, I'm going to replace it with the 2. That's going to give me 4 minus 1. That gives me 3. My y value is now 3. So my ordered pair is 2, 3. I can go up here and actually put in 3. So I found the range. My range is for wherever my domain is 0, 1, 2. For this function, my range is going to be negative 1, 0, and 3. Okay? These are the ordered pairs I create. Think of these again as inputs. These are my outputs after it goes through that machine. I hope that makes some sense. Try these a couple times and see what comes up.